Alright, like terms today. We're on lesson 18, and the title of the lesson is not only like terms, but addition of like terms. So we're going to add and subtract like terms. We're not going to multiply and divide them. When we multiply and divide terms, they don't have to be like. But when we add and subtract, they do. So here's kind of an example of what we're talking about. You'll see here, nobody goes to the store and then comes back and says, when I was at the store, I bought 2 apples and 3 bananas and an orange and 2 apples and 2 bananas. We always combine the things that we can group together. We would say we went to the store and we bought 4 apples and we bought 5 bananas and 1 orange. We'd be just grouping together the things that are alike. In math, we do the same thing with our terms. If they're alike, we add them. I probably actually shouldn't have clicked those off so fast. If I put them back, one more thing. These bananas, oranges. We learned about coefficients recently. The thing that makes us able to combine apples and apples is not the amount, but what it is. The 4 really in this case is just a coefficient. That's a coefficient. The 5 is just a coefficient. It doesn't really matter how many bananas. What matters is that we combine a banana and a banana. I guess maybe that is easier to show with the variables. But the coefficients won't matter. It'd be kind of like if, let's say, apples were represented by A, bananas represented by B, and oranges represented by C. And we said we had 2 apples, that'd be like 2A, plus 3 bananas, that'd be like 3B, plus 1C, so we usually just leave the coefficient of 1 off, plus 2 more apples, plus 2 more bananas. Again, how many terms do we have here? We have 1 term, we have 2 terms, we have 3 terms, we have 4 terms, 5 terms. And we're going to combine them and say, well, which ones are the same? And the coefficients don't matter. If I want to know if I can combine apples and apples, what matters is the variable, the A. These are both A's, so I can combine them to 4A. I have 4 apples. It doesn't matter. The 3 makes no difference as far as combining like terms. The coefficient, neither does the 2. This tells me how many B's I have. 2 tells me how many B's I have. It doesn't really help me determine whether I can combine them or not. What matters as far as combining is concerned is whether they're both B's. I can't combine a banana with anything else other than other bananas. So I've got 5B. I'm not sure why that's dragging that extra tail there. And then there are no other oranges to combine C with here. So this is kind of a fruit illustration, and we're going to learn about combining like terms when it comes to just algebraic expressions. If we were to go through an example here, first we're going to look at our test. I'm going to write a problem out. 3x plus 5 minus xy plus 2yx minus 5x. Alright, so here is an expression. We're going to simplify by adding like terms. So for a like term test, step 1, are all the variables the same? If yes, you can go to step 2. It doesn't mean they're like yet, it just means you can go to step 2. But if the variables are not the same, you can stop because they're not like terms. If they are the same, it doesn't mean they are, it just means you can go to step 2 to find out if they are. Step 2 says, are all exponents on all variables the same? If yes, congrats. Go ahead, you can add. You have like terms. Now, I don't think we're going to get into exponents at all yet, but we're going to cover them now anyway. For example, here's one straight from your book, and there are no exponents on any of these. So to start off with, let's circle our terms. Here's a 3x, here's a 5, here's a negative xy, here's a negative 2yx, and here's a negative 5x. So step 1, I want to try to combine like terms. Are all variables the same? So which terms have the same variables? Let's start with this one here. This first one. The only variable is x. So are there any other of these that have x in them? Here's one. Here's one. And here's one. These all have an x in. This one doesn't. He's already out. He doesn't even pass the first test. So if they do have the same variables, we go back and it says, are all of the variables the same? Well, no. This has an x. This has actually an xy. This one has a yx. This one has an x. So really now these two are gone also. So the only possibility of a like term with 3x is negative 5x. But we don't know for certain yet. So we've got to go to step 2 to find out. Are all exponents on all variables the same? If yes, then you've got like terms. In this case, yeah, there are no exponents. Really, it's an exponent of 1. And this is an exponent of 1. But we often don't write exponents of 1. So these two are like terms. I have 3x minus 5x. It's kind of like 3 apples minus 5 apples for a total of negative 2x. I like to cross them out. Don't know that I've dealt with them. So I go to the next. This one doesn't have any variables, but this one does here, this third term. I've got xy. I've got negative xy and positive 2yx. Are all variables the same? Yes, they both have an x and a y. Go to step 2. Are all exponents on the variables the same? Yes. They both have exponents of 1 on x and y. So this is kind of like saying negative bananas, negative 1 banana plus 2 bananas. It's not the same as the apples, the x, different, for a total of 1 xy. And it doesn't matter that this is listed as xy and this is yx, because it's just multiplication, and multiplication is commutative, so I can change the order anyway. And then finally I have plus 5 left over. So this really says the same thing as this whole thing. Here's a longer example. Here we've got exponents brought into the question. None of the problems you'll have on your lesson for today will actually have exponents, but they go with our test here, and eventually we're going to run into them. So we've got a squared minus ab plus 3a squared minus ba plus a squared b minus 3ab squared plus 4ab. So the question is, which of these terms are like terms and can be combined with other like terms? First, let's circle all the terms. A squared, negative ab, positive 3a squared, negative ba, positive a squared b, negative 3ab squared, and positive 4ab. So if I just start with the first one here, a squared, are there any other terms that have all the variables the same? So in other words, just a's. This one does not, it's ab. This one does, so here's a possibility. This one does not, it's ba. This one does not, it's ab. This one's ab. This one's ab. So the only possibility of being a like term is 3a squared. So a is the same, then we check the exponents. Are the exponents on the variables the same? A squared, yes. So this is like saying I have 1 apple plus 3 more apples. I have a total of 4 apples, or 4a squareds. So they're gone. Let's move on to the next possibility. We've got a ab. Are there any other terms with an ab? Well, here's an AB, here's an AB, here's an AB, here's an AB. So all of these possibly are like terms with negative AB. So the question is then, let's find out which ones are all exponents on all variables the same. Well, AB really means a to the first and b to the first. We don't write that, but that's what it means. So they really have an exponent of 1. So here's an a to the first, b to the first. Again, it doesn't matter if we changed it to BA. So this one is a like term. All exponents are the same on all of the variables. Here we've got an a squared b. This is an a squared, not an a to the first. Therefore, this is not a like term. Here we've got a b squared. Here the a is to the first, but the b is squared. Also not a like term. Here's an ab. Both have exponents of 1, so this would also be a like term. So it's like saying we have a negative orange minus another orange. That's negative 2 ABs plus 4 ABs. Means a total of positive 2 ABs. And I like to cancel them out, so I know they're taken care of. And then finally, positive a squared b and negative 3ab squared. Passes the first test, variables are the same, but does not pass the second test because this is a squared b and this is 3ab squared. This needs to be a squared b if it can be added with this. So really what we have is like a banana and negative 3 peaches. So this is the final simplified answer. These look like they're close, but they're not. All variables have to be the same, but not only all the variables, all the exponents on all the variables have to be the same. Just one more quick thing to mention about like terms. Like terms, we said earlier at the beginning, you really only have to worry about like terms when you're adding and when you're subtracting. That's when like terms matter. With multiplication, you don't have to have like terms. If we have a times a, the answer is a squared. A and a are like terms, we can add them, but the answer is not a squared, the answer is 2a. So there's a difference between multiplying a and adding 2a. Same thing here. A squared times a squared is a to the fourth. Later on we'll learn we can just add those exponents, which is different than a squared plus a squared. This is kind of like an apple plus an apple. So the answer is not a to the fourth, but 2a squared. So there's a difference between multiplying and adding variables. Now when we go over here, we can see that we can multiply terms that aren't like. We just can't add them. A times a to the second is a to the third. If we thought about that, this would be a times a squared is a times a, so it's a times a, so it's a to the third. However, a plus a squared can't be done. They're not like terms. You can't add them. It's like adding an apple and an orange. So although we can multiply them, we can't add them. Same here. I can take 2a times ab. That just means 2a times a times b. It's all multiplication. 2 times a times b. You'd get 2a squared b. It's okay to multiply terms that aren't like, but you can't add them. 2a plus ab doesn't work. They're not like terms.